In a galaxy far, far away, we found the most luminous object ever discovered, Saturn 15 Lao AH. Astronomers were left scratching their heads, wondering what kind of beast could produce such a mind-boggling amount of energy. But just when they thought they had this cosmic enigma all figured out, this object vanished into the depths of space, leaving behind nothing but a faint memory and a few bewildered astronomers. Fast forward to today, and it seems the universe has decided to play a cosmic prank on us. That's right, folks, Saturn 15 LH is back. And now it's brighter than ever. So, let's take a look at this impossibly bright space object. This event was first detected on June 14, 2015. We noticed it in the southern constellation Indus. It was located within a faint galaxy, which just goes to show that sometimes the brightest things come from the most unexpected places. It's like finding a diamond in a pile of rocks, or a chocolate chip in a batch of oatmeal raisin cookies. No offense to oatmeal raisin lovers out there. Saturn 15 LH was so luminous that if it were in our own galaxy, it would shine brighter than the full moon. Imagine that, no night, no stars, just this mysterious thing lighting up the sky like a giant flashlight. Wouldn't that be cool and kinda terrifying? But in all seriousness, it was a fascinating astronomical event. At its peak, it was 570 billion times brighter than our sun. That's so bright, you'd be blinded by the sight of it even from afar. So, picture this. It's 2015, and astronomers discover the brightest object ever observed. It was one crazy discovery, because scientists had no idea what it could be. Is it a supernova? Is that TDE? What in the world is this thing? But then, as soon as they started to study this thing, it started to fade away. That was a huge bummer. Scientists could only sit with their theories and wonder what it could be. But then, against all odds, Saturn 15 LH did the astronomical equivalent of a double take, and suddenly got brighter again. Astronomers were like, wait, what? Is that thing coming back from the underworld? For 40 days, its ultraviolet radiation charged up and increased fivefold. Then, it plateaued for a couple of months before finally dropping away again. And then astronomers were like, okay, that's just weird. So what is this thing, and what caused its resurgence? Well, there are a few theories. A supernova is like a star's grand finale. When a star runs out of fuel, it reaches the end of its life. And then, it undergoes a cataclysmic event, releasing a tremendous amount of energy and light. And this beautiful, crazily bright event is called supernova. It's like the ultimate mic drop, except the mic is the entire star. So, some astronomers think that this mysterious object might be a supernova, but a really, really big one. If once it was a star, it probably was 100 times more massive than the sun. We've never seen such supernova before, but maybe this star was gigantic and really loved attention. Next, we have the magnetar theory. So during the supernova event, the core of the star collapses in on itself and forms a very dense object. Imagine a marshmallow the size of a mountain. Now, squeeze that marshmallow until it's about the size of an actual marshmallow. It's so dense that if you could somehow stand on the surface of a neutron star, which you can't because you'd be squashed by gravity, you'd weigh as much as 1 billion elephants. That's kind of what happens to a star after its fuel runs out. This super dense leftover core is called a neutron star. So, you could say that a supernova is like a star's big send-off party, where it goes out in a blaze of glory, and a neutron star is what's left over after the party's over, like the empty pizza boxes and beer cans left after a wild night with friends. So, some scientists think that Saturn 15 LH might be something like that. They think that it was a star that ran out of fuel and became a neutron star. Then it spun so fast that it bursted out super hot jets of material. It's like when you spray water out of a hose. But the water is really, really hot. These jets can heat up the stuff around them and make the supernova even brighter than usual. But our mysterious friend was even brighter than that, so this theory might be wrong. But that's okay, we still have a few others. Another theory says that it was caused by the collision of two neutron stars. Such a collision would cause a real grand spectacle, with clouds of glitter and all that stuff. Another cool idea is that ASN 15LH might have been caused by a supermassive black hole tearing apart a star that got too close. It's like if a hungry monster grabbed a hold of a tasty treat, but instead of eating it, it just tore it to shreds and made a huge mess. This one is probably the coolest. And lastly, the most boring explanation. This theory suggests that this mysterious object might not be as bright as we think it is. Instead, its light is being magnified by a galaxy cluster or some other massive object in space. It's kind of like if you put on a pair of glasses that make everything look bigger and brighter. So, these were all the possible explanations of this event. And if these mysteries weren't enough, then remember that scientists have no idea why this object could start glowing again. They thought that maybe it ran into some nearby gas that made it a bit brighter, but then that checked if it was the case and didn't see anything. So, 200 in favor of the weird bright thing. In other words, ASN 15LH remains a mystery. It's still keeping astronomers on their toes and saying, "You thought you knew everything about supernovae. Think again, puny humans." And this isn't the only mystery in our universe. There are tons of things that scientists still can't explain. For example, have you heard of dark matter? No, it's not a group of goth particles, but it's something even more mysterious. Dark matter is a substance that makes up about 27% of the entire universe. Yet, we can't see, touch, or taste it, even though it's hiding in plain sight. Scientists know that it's there because it has a gravitational pull on visible matter, kind of like how a good cheeseburger has a gravitational pull on me. The weirdest thing about dark matter is that we have no idea what it's made of. It's a mystery box, except we can't even see the box itself, and the mystery of dark matter still keeps scientists up at night. Another dark mystery is the elusive and enigmatic dark energy. It makes up about 68% of the universe, but we still have no idea what it is. Both of these are called dark because they don't interact with light or any other form of electromagnetic radiation. In other words, even though we know they exist, we can't see them directly. Can you imagine? We can only see about 5% of the universe. Who knows what else might be hiding there? One day, scientists noticed that the universe was expanding faster and faster over time, but it must be impossible, right? After the Big Bang, the expansion of our universe should gradually lose speed, like everything in nature. However, this wasn't the case. So, something must be pushing it, right? And that's how scientists came up with dark energy. A mysterious force that's thought to be pushing the universe and making it accelerate over time. But what causes it? Scientists still have no idea, and until we figure out what all these things are, they will remain one of the greatest mysteries of our universe. So, our mysteriously bright object isn't even one of the biggest puzzles. We still have tons of things to explain. Who knows what other secrets the universe is hiding from us? Either way, let's hope that one day we'll learn more about our world and answer these questions. Scientists have a wild theory. What if our entire universe is actually inside a black hole? This is called the black hole cosmology. Some scientists have the idea is that our observable universe and everything we see around us might be tucked inside a black hole, which exists inside another parent universe, or even multiverse. And then this multiverse could also be a part of the bigger one, and so on. Like a stacking doll. Sounds like pure science fiction. But this is based on some curious facts. When scientists create the timeline of our world, they say that everything started from a singularity. If you kept squeezing a giant ball smaller and smaller, at some point, it would get super dense before it crushed. Well, it's hard to imagine, but in space, it's possible to squeeze a crazy amount of mass into a teeny tiny point. This point is called a singularity. The matter gets crushed into an infinitely small space, less than an atom, and it holds all the same mass of everything, while taking basically no volume. Inside this singularity point, things get so intense that the normal rules of physics just stop working. Everything we know, time, space, matter, breaks down and can't be applied anymore. Basically, what happens from now on is beyond our understanding. So scientists say that this was the starting point of our world. When the Big Bang happened, it's like this tiny dot with everything inside it expanded to everywhere. This started forming the universe as we know it. And here's the thing. Scientists assume that singularity also exists deep within the black holes. General relativity says that a black hole is born when something really big, like a huge star, collapses under its own weight. Gravity gets stronger the bigger the mass is. With a mass of a huge star tens of times bigger than our sun, this little point would have an unbelievable gravity. That's why it starts sucking in all the stuff around it and curves the fabric of space-time so much it looks like a hole in space. And this would be the center of a black hole. It's a dot where all these things fall into and get crushed into an infinitely dense point. So, could our universe itself be just a little singularity dot inside of a huge black hole inside of another universe? That would be wild. Now, it's not that easy to compress something so much that it literally warps space-time. You'd need to squeeze it like crazy. If you wanted to make a small black hole, like a human size, you'd need to shrink them down to the size of an atomic nucleus. If you want a black hole the size of a chickpea, you'd have to compress our entire planet to that. But our universe is 99% empty space. There are trillions of miles of just nothingness between the stars. If you were to pack all the matter in the universe together, the result would be surprisingly small. Everything around us, including galaxies, stars, planets, and dust, would only fill about 1 billion cubic light years. It would be a cube about 1,000 light years on each side. For comparison, our Milky Way alone is 100,000 light years in size. That's how sparse the universe is. But at this density, it would also be very, very massive. The resulting mass would likely collapse into a black hole. And here's the wild part. This resulting black hole would be roughly the same size as the universe itself. It would also have the same mass and energy, as well as the same average density. The size or radius of the black hole grows together with its mass. The more stuff it eats, the bigger it is. But its density works the other way around. The black hole gets less dense as it grows. For a size that big, of our entire world, it would be pretty sparse as well. And it's not the only coincidence. We have this thing called the Hubble radius, also known as the cosmological event horizon. If we imagine our observable universe as a giant bubble, then think of its edge like the farthest part of the universe we can see. When you stand in a field and look around trying to see as far as you can, your eyes will draw a circle. This is like that. There might be more beyond that point, but we'll never know. Beyond this horizon, the light from distant parts of the universe will never reach us. That's because light travels at a certain speed, and the space between us and those regions is expanding too quickly. It's like running towards something while the super strong wind tries to blow you away. Until we stay on Earth, we're cut off from those far-off corners forever. The black holes have something eerily similar called an event horizon, or the Schwarzschild radius. This is the point of no return. It's this imaginary line that's often depicted as a light contour around the black holes. Anything crossing an event horizon falling inside is lost forever. No light, no matter, no information can escape from there. Black holes' gravity is way too strong, so they're perfect space vacuum cleaners. And as we mentioned before, if we create a black hole the size of the universe, they would have the same mass and the same event horizon radius. While some scientists think these could just be random coincidences, others believe it's a clue that our universe might actually be inside a black hole. The theory also suggests that our universe might not be the only one. It could exist in one of many black holes scattered throughout a larger multiverse. In this crazy model, each one of them, both in our world and our parent world, could lead to its own universe, with its own set of physical laws and structures. That would be some weird chain. There's this theory that says that universes could be born inside of black holes. Sort of. It's called the Einstein-Cartan theory. This idea talks about singularity as well, but in a different way. It says that instead of collapsing into an infinitely dense dot, the matter might create a wormhole. This is like a tunnel through space and time. This wormhole, also known as an Einstein-Rosen bridge, could connect two different places of our universe. In that case, one side of the tunnel is the black hole, and on the other side, there could be a whole new universe forming. So, it could work like a teleport. As soon as you pass the event horizon, you travel to the new world. But in that case, there should be an exit. Some scientists made it up and called it a white hole. It doesn't literally exist, not as far as we know, but it could be possible, somewhere on the other side. It would serve as an exit of a wormhole, an area where matter is always ejected instead of pulled in. So it's like, you can't throw anything in there, it would get expelled immediately. That's all purely hypothetical, of course. All this stuff fits well into the concept of the Big Bounce. This idea says that instead of our universe beginning with a singular Big Bang, it bounced from a previous state of collapse. Remember the squeezed ball analogy? Well, maybe there used to be another universe ball that got super compressed to a minimum size before rebounding and expanding again. So, instead of a universe born from nothing, we might live in one that's a cosmic recycling of another. There's also another version of this theory, sometimes called shockwave cosmology. This idea says that the Big Bang could have been caused by a boom inside a black hole, and this could create the expanding universe we see today. As the universe expands and the matter density decreases, the black hole would eventually transform into a white hole, the reverse of a black hole, where matter is expelled instead of pulled in. But even though we have all these interesting connections, they're not evidence. There are no experiments or observations that could prove or disprove these wild theories, so they all remain speculation for now, but at least it's fun to speculate.
Okay, here's the deal. Something is bound to happen that can affect everything we've ever known about space and time. You've heard about black holes, right? That denser-than-life type of phenomenon that usually exists in the center of galaxies? Two of them, located 9 billion light-years away from Earth, are expected to collapse into each other. And my oh my, I do not want to be around to see that. Let's get one thing straight. Black holes are the most powerful things in the entire universe that we know of. If they decided to go all Revenge of the Sith on us, we'd be doomed. A black hole was once a massive star that went supernova, meaning that the star collapsed onto itself, and the sheer magnitude of the explosion created a black hole in its place. Oh, by the way, black holes do not pull things inside like a vacuum cleaner. That's just a popular myth. Say we were to replace our sun with a black hole at the center of the solar system. Not much would change, except that maybe we'd all freeze. Yep. But black holes can do something much worse than vacuum stuff. They can delete the universe itself. If a black hole was to follow a normal timeline, it would go from its creation to total disappearance. But this process is very, very slow. I'm talking about billions and billions of years before a black hole loses its mass entirely. That happens because they're constantly losing their mass every single second. Black holes radiate their mass away, like a boiling teapot loses its water as steam. Yet, things rarely go as planned, both in our lives and apparently in the universe itself. So it wouldn't be that much of a surprise to find out that two black holes are en route to collapse. That's what scientists have found out recently. And let's just say that this is one of the reasons why the scientific community is freaking out just a little bit. The first question that comes to mind is, what does that mean for us humans? Total annihilation? No need to be this dramatic. The best case scenario, we'd be in for an interstellar type of experience. Roll me in, please. Let's rewind a little bit to understand how this would happen. 45 years ago, a group of scientists began noticing a weird behavior coming from a galaxy far, far away. The galaxy is found 9 billion light-years away, and its scientific name is a mouthful, but let's just call it Super Far Away Galaxy. You might be asking yourself, well, how did scientists observe this black hole so far away if it doesn't emit any light? Good question. That's because black holes gather disks of gas around them, and they emit some of this material into space. These jets can be detected from a distance of millions of light-years. Now, if these hot gas jets are directed towards space, then scientists give these black holes a special name, blazars. A particular blazar has been gaining worldwide attention recently. Long name, but let's just call it Andy. Imagine you're a scientist at Caltech and you're looking at a blazar in your radio telescope and you notice its strange behavior. Its brightness goes on and off, like the ticking of a clock. At first, you don't understand what's happening over there in a distant corner of the galaxy. But then, you realize there must be another black hole circling the first one. In other words, scientists discovered that Andy was being orbited by another blazar, Gomer. And the regularity of their twinkling can only mean they are close to a total collapse. It gets worse. Each of the two blazars is estimated to be a few 100 million times the mass of our Sun. Have you seen our Sun? It's huge. It's already 333,000 times the mass of our Earth. This means we're destined to face something out of our league. Now, this is not the first time scientists have detected something like this. In September 2015, the LIGO Observatory detected a collision of two black holes. Each of them was as heavy as 30 suns, and an equivalent of 3 solar masses was released once they crashed into each other. And guess what? This gravitational wave passed through Earth at the speed of light, but we really weren't affected by it. Maybe you were sleeping and felt something weird in the air, but nothing significant happened to us as a species or to our planet. But that's because the blast was weak. The thing is, the expected collision between Andy and Gomer will send unprecedented gravitational waves throughout galaxies, and they will reach the solar system. But what is this shock wave actually capable of doing? Well, it could stop our Sun from releasing gas for a few minutes, which means it would stop heating the solar system. So, let's say you were going about your summer day, and out of the blue, the atmosphere froze for a few seconds. Doesn't sound too nice, huh? But that's actually a better possibility than the next one. In one of the worst-case scenarios, a blast from the collision between Andy and Gomer could break bonds between atoms and make everything disintegrate. You, me, your cat, we'd all turn into flying particles floating in the vacuum of space. This may sound scary, but scientists say that an atom is made out of 99% empty space. This means that everyone on this Earth, all 8 billion of us, and everything that exists, planets, objects, animals, are all made up of 99% empty space. So perhaps all that Andy and Gomer would do is separate all of our atoms and desolidify us. Then again, the blast could mess with the fabric of space and time as we know it. You remember Albert Einstein, right? Crazy hair? He's the name behind the theory of relativity. Einstein discovered that time is relative. It's always dependent on the observer. This would mean that time is not the same throughout the cosmos. Why though? Well, because Einstein's theory of relativity is also a theory of gravity. Einstein discovered that gravity is the effect that objects have on the fabric of space-time. Every object that has a mass, including you, me, your cat, and our planet, creates a warp or a distortion in the fabric of space-time that causes it to bend. The bigger the mass, the bigger the gravitational force, and the bigger the distortion on the fabric. It may sound complicated, but hey, this is what creates different perceptions of space and time throughout the cosmos. This is why you'll age differently on Earth and on Jupiter. This is why time passes completely different for astronauts on long missions and for people that remain on Earth. And this is why a collision of two mega blazars could mess with our perceptions of space and time due to the sheer force of its gravitational shockwaves. Got it? Not to mention that black holes are already a huge warp in the fabric of space-time. You remember that interstellar scene, right? Where the lead character bends the space-time continuum through a black hole? Now, don't try this at home though. As far as we know, anyone who chooses to go inside a black hole has no guarantee of making it home again. Scientists say that this blazar explosion will happen in approximately 10,000 years. But wait a minute. If this blazar lies 9 billion light-years away from Earth, it means that these two black holes should have already collided long before our solar system and home planet were born. You see, the solar system was born around just 4 billion years ago. And since it takes us 9 billion light-years to receive the light emitted from the blazars in the first place, this means that the collapse of the two blazars already took place, and it'll reach Earth 10,000 years from now. This means the shock waves are already making their way through the galaxies at this very moment. But still, it's not something even your great-great-great-great-great-great-grandchildren will be around to see.
They aren't supposed to exist. No one expected to find them. Scientists can't explain how they formed. And still, the James Webb Space Telescope has found them. These 6 galaxies, as massive as our home Milky Way, are full of mature red stars. They're so far away from us that they look like tiny reddish dots, even to this extremely powerful telescope. Astronomers have analyzed the light coming from these galaxies and estimated their age. They appeared 500 to 700 million years after the Big Bang. So far, nothing surprising. Galaxies that young aren't exactly rare. Scientists think that our first star clusters could have sprung up soon after the universe left the so-called Dark Ages. Those were the first 400 million years of its existence. At that time, only a thick fog of hydrogen atoms filled the cosmos. What is extremely bizarre about these galaxies is their tremendous size and the age of the stars inhabiting them. But this doesn't coincide with the existing ideas about what the universe looked like and how it evolved in its early years. Plus, it doesn't match with earlier observations made by the Hubble Space Telescope, Webb's less powerful predecessor. So, according to scientists, what are early galaxies supposed to look like? The answer is simple: young and small. And indeed, previously, most early universe galaxies we found were just space babies, blue and small. They seem to have appeared out of the primordial cosmic soup just recently and were still building their early stars and other structures. Most young stars are actually blue. As they age, they acquire a reddish glow after burning through their star fuel and cooling down. That's why astronomers were not ready to see old red stars in those ancient galaxies Webb telescope was built to discover. Another thing they weren't ready to spot was galaxies more massive than a billion suns, and still, it happened. The most massive galaxies discovered recently seem to have masses just twice or 4 times lower than that of the Milky Way. And the most astounding thing here is that these galaxies were already that big when the universe was a mere 3% of its current age. But before astronomers start rewriting their theories, trying to explain how such huge galaxies formed so fast after the Big Bang, we need to make sure that what we're looking at isn't some other space phenomenon. Even so, most alternative theories need totally new concepts as well. One of them goes like this. Perhaps stars in the early universe emit light in some unusual, exotic way. And since astronomers didn't know about it, they didn't include this possibility in their models. Or our understanding of how stars form might be inapplicable to the early universe. If any of these theories turns out to be true, it'll overturn our understanding of star formation altogether. Now, how about we talk about the device that helped astronomers to discover those bizarre galaxies? The James Webb Space Telescope is an absolutely stunning piece of equipment, which is around 100 times more powerful than the Hubble Space Telescope. And the latter has observed places that are 13.4 billion light-years away. The James Webb Telescope is also on the pricey side, to put it mildly. Even though originally, the cost of the telescope was estimated to be just $1 to $3.5 billion. The whole development process cost around $10 billion. For comparison, it cost NASA $4.7 billion to build and launch the Hubble telescope. It was another $1.1 billion to fix it in orbit. Even though the James Webb Space Telescope itself is 3 stories high and the size of a tennis court, its mirrors are the lightest large telescope mirrors of all time. During the manufacturing process, they underwent a 92% reduction in weight. When you look at them, the telescope's mirrors seem to be gold, but in reality, they're made of beryllium. This is a steel gray, lightweight, and brittle metal. A gold coating is applied to each mirror, that's true, but they can't be produced entirely out of gold, since this precious metal tends to expand and contract, even with small temperature changes. So, the total amount of gold in the James Webb Space Telescope is less than 2 ounces. That's a golf ball-sized piece of gold. And the gold plates covering the mirror are only 1,000 atoms thick. As for the telescope's abilities, it would be able to clearly see a US penny from 24 miles away and a football from 340 miles away. James Webb's telescope side is cooling itself down, and its temperature doesn't rise higher than negative 370 degrees Fahrenheit. That's cool enough to make liquid nitrogen. A truly enormous 5-layered sun shield surrounds the telescope and reflects away as much sunlight as possible, letting the telescope stay cool. JWST is believed to be able to detect water on distant exoplanets. For a long time, astronomers have been discovering planets orbiting stars outside of the solar system by monitoring slight dips in stars' light. Such dips happen when planets pass in front of them. Plus, it's possible to read unique signatures in the light. This can tell us about a planet's chemical composition. And the strongest and most readable signatures happen within the infrared spectrum. And guess what? James Webb has state-of-the-art infrared instruments. They can help scientists spot new planets and even identify the presence of water there. The telescope was launched near the equator because Earth spins a bit faster there. And this gave the rocket some extra push. When the James Webb Space Telescope runs out of fuel, it'll keep orbiting the Sun indefinitely. On the other hand, even though the telescope wasn't actually designed to be serviced or upgraded, it might potentially be refueled with the help of robots. This would extend its lifespan. Interestingly, at first, astronomers were sure that finding something exciting with the help of James Webb would take time. They thought that the first discovered galaxies would be so small and dim that the telescope would only find some remote candidates at best. But it didn't go as planned. As soon as the first images were released, scientists started finding countless galaxies, bright, large, and impressively old. The competition is still on. One research group after another spots new record-breaking worlds. One astronomer even said that the scientific world was freaking out since no one had actually expected such impressive results. One of the main goals of the Webb telescope is to observe the light from the very first stars and galaxies in the universe. Unfortunately, the farther away an object is, the faster it's moving away from us. And the longer the light has to travel, the more it stretches towards the infrared side of the spectrum. This is called redshifting in astronomy. But thanks to its infrared equipment, James Webb can reveal previously invisible worlds to us. So, thanks to this telescope, we've managed to see incredibly distant galaxies that were born around 3.8 billion years ago. It means that the light JWST detected took more than 13 billion years to reach Earth. Can you imagine that? But one of these galaxies stands out from the rest. It appears to be the oldest galaxy astronomers have discovered so far. It's called Glass Z13, and it dates back to a mere 300 million years after the Big Bang. The previous oldest galaxy scientists identified was found by the Hubble Space Telescope, and it dates back to 400 million years after the Big Bang. During that scarcely probed era, the very first galaxies and stars started to appear. But how exactly did this process unfold? No one knows for sure, yet. It might have depended on the laws of some exotic physics, including the influence of dark matter and dark energy, or some poorly investigated communication between gas, dust, and starlight. With the help of the Webb telescope, scientists can now test their theories about what was happening out there after the birth of the universe.
At first, it may seem like the sun is burning, but it's actually not true, because the burning of our star isn't chemical combustion, it's nuclear fusion. The sun can't run out of oxygen or stop burning because it doesn't use oxygen to burn. Regular carbon combustion requires oxygen. As soon as there's no oxygen, the process of burning stops. Now imagine a candle. If you cover it, it doesn't have access to oxygen anymore, and the process of burning stops. But in nuclear fusion, the nuclei of atoms are fused together to make new, bigger nuclei. Such changes cause atoms to become new elements. Nuclear fusion doesn't require oxygen or any other material altogether. You just need enough pressure or heat to squeeze the nuclei of atoms close enough for them to overcome their electrostatic repulsion and bond into one nucleus. In 2027, two teams of astronomers discovered a cloud of water floating in open space. It was the largest and farthest reservoir of water ever detected in the universe. It's a cloud of water vapor surrounding a huge black hole called a quasar, 12 billion light-years away from Earth. The environment around the quasar must be unique to somehow produce such giant masses of water. It was formed by energy waves colliding hydrogen and oxygen atoms together. The cloud contains 140 trillion times the entire volume of water on our planet. It could provide each person on our planet with a planet's worth of water 20,000 times over. Wow! Even cooler, astronomers believe this water cloud appeared just 1.6 billion years later than the universe itself. Scientists consider it another demonstration that water exists throughout the universe and was present already during its early days. At the same time, before this discovery, scientists had never found water vapor present so far back in the early universe. There is water in our home Milky Way galaxy, but most of it is frozen in ice. Not only water is floating out there in space, alcohol too. In 2009, scientists were examining a massive cloud of gas and dust in the center of our galaxy when they stumbled upon a surprise. There was ethyl formate within the cloud. This chemical is responsible for the sweet flavor of raspberries. They also found one more cool region. This one was brimming with ethyl alcohol, the same type found in many beverages. At the North Pole of Saturn, a mysterious storm is raging. It's ginormous, spanning an area larger than our planet and showcasing a beautiful but baffling hexagonal pattern. No one has understood yet why the storm has such a bizarre shape. After the hexagon was first discovered in 1987, it remained hidden in darkness up to the moment when sunlight exposed it again. Soon afterward, the Cassini spacecraft, designed to explore the Saturn system, provided a series of captivating images and even a video of the hexagonal storm. It turned out to be colossal in size. Its estimated depth is around 180 miles, and the eye of the storm is 50 times as large as the typical storm on Earth. The storm is also changing its color from blue to gold. Winds of hydrogen and ammonia surround the storm and move at more than 300 miles per hour. The storm has several centers. Some of them move clockwise, and others follow a counterclockwise direction. The largest vortex appears to be white, and it's twice larger than the standard hurricane on our planet. As for the hexagon itself, it's a jet stream made up of atmospheric gases. Experts refer to it as just a current of air and weather features. But there is one intriguing detail: a vortex sitting at a higher altitude than Saturn's clouds. It looks like a large towering structure. Saturn's auroras, triggered by the planet's magnetic field, are located atop of the hexagon, giving its appearance a mystical vibe. Astronomers have found a giant, likely active volcano near Mars's equator. It was literally hiding in plain sight. It's ancient and deeply eroded, but seems to be still functioning. There may even be remnants of a glacier ice near its base. That's why this discovery might indicate a promising new location to search for life, as well as a potential destination for future human and robotic exploration. The structure is still awaiting its official name. At the moment, it's referred to as the Noctis volcano. It reaches a height of 29,600 feet and spans an impressive 280 miles across. Such a giant size indicates that the volcano has been active for a very long time. In its southeastern part, there's a thin, recent volcanic deposit, and beneath, glacier ice might still be present. At a distance of 700 million light-years away from Earth, there's a gaping hole, a blank void with no galaxies, stars, planets, or asteroids, literally nothing. The void is a roughly spherical region about 330 million light-years across. Our home Milky Way galaxy could fit there billions of times over. That's the mysterious Boötes Void. It lies in the constellation of Boötes, the herdsman driving the plow around the North Pole. At first, this void had the name of the Great Nothing, but later it was given its current name. Now, we know that galaxies look like a giant web. Most of them are parts of long structures called filaments. Those wind through the cosmos, and when they meet, they form regions with a high concentration of galaxies. These regions are what we know as galaxy clusters, but between these clusters and threads, there are enormous empty voids that hardly contain any galaxies. Such voids actually make up almost 80% of the observable universe, and most of them are huge, from 30 to 300 million light-years wide. The Boötes Void is one of the most massive ones, and has even earned the title of supervoid. Astronomers think it might be the result of a few smaller voids merging together. There is a diamond planet out there that orbits a star in the constellation of Cancer, completing one full rotation in a mere 18 Earth hours. The planet's scientific name is 55 Cancri E. The radius of this faraway world is twice as large as Earth's, and its mass is 8 times greater. The planet is scorching hot, the temperatures on the day side reaching almost 5,000 degrees Fahrenheit. But the coolest thing about 55 Cancri E is that, according to some specialists, at least a third of the planet's mass could be diamond. That's the equivalent of around 3 masses of our home planet. Sounds like big money floating out there in space. How about we calculate how much this planet could be worth? Wait, someone has already done it, and the number is astronomical, pun intended, of course. It's 26.9 nonillion, and if you're confused by this number as I am, that's 26.9 followed by 30 zeros. Now, for comparison, one of the most expensive diamonds on Earth ever is the Cullion. It costs a whopping $2 billion, and its original weight was a mind-boggling 3,106.75 carats. It was, and still is, the largest raw gem diamond ever found. Later, it was cut into many small diamonds. The largest of them is Cullion 1. which also goes by the name of Star of Africa. It has a carat weight of about 530, but imagine how much bigger and more expansive the Diamond Planet is. Nebulas are gigantic clouds of gas and dust, and some of them can have really unusual shapes, as if they were made this way on purpose. With time, gravity starts to pull these clumps of dust and gas together. They grow larger and larger, and their gravity gets more powerful. One day, this mass becomes so big that it collapses under its own gravity and forms new stars. Among some of the most beautiful nebulas out there, we must mention the Butterfly Nebula. Its wingspan is more than 3 light-years, and the structure inside the nebula is one of the most complicated ever observed. The central star, a white dwarf, is heated to an incredible 450,000 degrees Fahrenheit. It means it formed from a giant gargantuan star, likely more than 5 times the size of our Sun. The white dwarf is surrounded by a thick disk of dust and gas at the equator. It's what probably makes the whole structure look like an hourglass or a butterfly. The Ring Nebula looks like a giant cloud of dust and gas surrounding an old, almost extinguished star. At first sight, it does look like a ring, but astronomers say the nebula isn't a bagel, it's a jelly-filled donut. They must be hungry. The deep space colorful object, more than 2,000 light-years away from Earth, is actually a ring that wraps around a blue ball-shaped structure. Each end of the structure sticks out of the ring's opposite sides. The pillars of creation look like something out of this world. See for yourself. They're located 7,000 light-years away from Earth in the Eagle Nebula. That's a young cluster of stars just 5.5 million years old. On a space scale, they're just babies. Once, the Hubble Space Telescope managed to take an image of several dark silhouettes near the nebula's center. And now you can see them with your own eyes. Those are the so-called pillars of creation, an active star-forming region. Look at this famous image. The blue colors represent oxygen, red is sulfur, and green means the presence of both hydrogen and nitrogen. The pillars are also bathed in the ultraviolet light coming from a nearby cluster of young stars. Unfortunately, the winds from those stars are slowly but steadily eroding the magnificent towers of gas and dust. Far out in space, a ghostly super-ancient galaxy is floating all alone. It shines with a faint glimmer of starlight and has hardly changed for billions of years. Astronomers have no idea why it's there or how it formed. Meet DGSATI, a living fossil galaxy. It's as big as the Milky Way, but is nearly invisible because its stars are spread out incredibly thinly. But what makes the galaxy so unique is that it's sitting all alone, unlike other galaxies of this kind, which are usually found in clusters. It might mean that DGSATI was formed in a different era, probably a mere 1 billion years after the Big Bang. If it's true, the galaxy is a real living fossil. Astronomers have discovered the most massive stellar black hole ever spotted in our home Milky Way galaxy. This newly found space monster is 33 times bigger than the Sun and sits 2,000 light-years away from us. Until recently, the largest stellar black hole found residing in our galaxy has been around 20 times as big as our star in terms of mass. As for the average stellar mass black hole, it's usually about 10 times as hefty as the Sun. Scientists spotted the giant black hole after a star started to wobble while orbiting in that area. The black hole got the name of Gaia BH3. The proximity of this space object to Earth makes it the second closest to our planet black hole ever discovered. The nearest one is called Gaia BH1. Makes sense? It's hanging out around 1,560 light-years away from us. This uncomfortably close neighbor has a mass of around 9.6 times that of the Sun. That means it's way smaller than the newly found black hole. Gaia BH3 is located in the Aquila constellation. From Earth, it seems to have the shape of an eagle. Interestingly, Astronomers didn't expect to find a high-mass black hole lurking so relatively close to Earth and remaining undetected for so long. Now look at this marvelous exoplanet. It resembles a giant eyeball hanging out there in space. But it isn't the coolest thing about it. This distant world, identified in 2017, is one of the most promising places for finding life outside our solar system. The exoplanet is called LHS 1140b, and it shows signs of having a global ocean capped in ice. It's that very iris, a huge region around 2,500 miles across, which is constantly gazing at its host star. The planet has a radius of about 1.73 times the radius of Earth, and is 5.6 times as massive as our home planet. The giant eyeball planet orbits much more closely to its star than Earth does. It needs just around 25 days to complete an entire orbit. If the star were similar to our Sun, such a distance would definitely be too close for life to appear on the planet. But instead, it's a cool and dim red dwarf. That's why the exoplanet lies in the habitable zone of its star, where it's not so cold that all surface water would freeze, and not so close that this water would steam away. At the moment, LHS 1140b looks like the most promising candidate for hosting life in our planetary neighborhood. Solar flares are extremely powerful bursts of electromagnetic radiation that can last from minutes to hours. They occur when there's some magnetic disturbance in the Sun. Then, magnetic field lines in the atmosphere of our star get tangled and snap. This releases giant amounts of excess energy, including ultraviolet radiation and intense X-rays. These twisted lines appear in sunspots. Those are darker and cooler regions on the surface of the Sun. They form when magnetic fields that used to hide deep within our star rise up to the surface. As for coronal mass ejections, or CMEs, which are launched by solar flares, they're sent outward into space. They hit planets, satellites, and basically any objects in their path. Those that come across Earth trigger geomagnetic storms, which in most cases result not only in beautiful auroras, but also in power grid failures and satellite malfunctions. All these extreme solar phenomena, CMEs, sunspots, and solar flares, get much more intense during the peak of the Sun's 11-year-long activity cycle. It's known as solar maximum. Right before this event, the Sun steps up its activity. It starts to spit out giant blobs of fiery plasma, emits powerful streams of radiation, and grows planet-sized spots. At first, experts were sure that the current solar cycle would reach its peak in 2025. But judging by recent numerous sunspots, intense solar storms, and some other rare solar phenomena, solar maximum is likely to arrive sooner than that. This planet is as light as a piece of fluff stuck to your jacket. In the scientific world, its name is WASP 193b, but we'll call it the Cotton Candy Planet. It's located around 1,200 light-years from us. We'll never see it with our own eyes, but scientists say the Cotton Candy Planet is pretty much Jupiter's bigger, bouncier cousin. It has an extremely low density. Combined with other factors, like its high temperature and the infrared brightness of its host star, it makes it special. Interestingly, the planet's radius is just 1.46 times the radius of Jupiter, but its mass is a mere 0.139 times of our gas giant. May I have a close-up here, please? Thank you. See how fluffy it is? It would be absolutely impossible to stand on its surface should you ever reach this distant world. It's not often that you can meet something like WASP 193b at a planetary party. Such planets are rare. Their fluffiness might be caused by their planet stars. Those heat them, puffing them up like a marshmallow that's seen too much campfire action. The planet's super low density makes it a real anomaly among those 5,000 plus exoplanets we have already discovered.